All right, so I want to do another uh, integral that requires u substitution. So what I'm going to do is um, I am going to find the indefinite integral of sine ax, sine of ax dx. All right. So if I observe this integral over here, okay, this expression, I notice, and over here, this is a here, it's just going to be some constant. It could be number 2, so just a constant, okay? That's what the a is. So it could be 2, it could be 3, it could be 15, it could be the square root of 2, just a constant. All right, so if I take the derivative of this inside, it actually becomes just the letter a, or the number a, the constant a. And in respect to x, of course. And as far as the x is concerned, the derivative of the inside is outside. What do I mean by that? Well, the derivative of x is just going to be x to the 0, which is 1. So it's going to be outside here. So I can use integration, okay, by u substitution. So what I'm going to do is I'm going to let, okay, u equals to ax. And so if u is equal to ax, I am now going to differentiate this in respect to x. So this implies then that du dx is going to be equal to a, precisely as stated. So, and I multiply by dx, both sides. So this implies then that du is equal to a dx. All right, fantastic. And now what I can do is I can divide both sides by a, so I get that, okay, we get that du divided by a is equal to dx. Okay, so I have dx here, and now I'm going to substitute this and get a new integral. Okay, so what I'm going to get is the following integral. I'm going to get the integral of sine, okay, u, and then dx is equal to du over a. As I said, a is a constant, right? So a is a constant, right? So I can take this constant out, or I can leave it there, so this actually really just equals to 1 over a times the integral of sine u du. Now, the antiderivative of this, is just going to be equal to negative 1 over a cosine of u, right? Plus c, because I'm dealing with an indefinite integral, plus a constant c. So now what I'm going to do is I am going to go back and recreate the indefinite integral here of this expression using what I have here. All I have to do is substitute u equals to ax in this, and I will obtain the integral, okay, I will obtain the indefinite integral of this expression here. Okay, so I'm going to write the answer to this indefinite integral in here. So the answer is going to be that this is equal to negative 1 over a cosine of u is equal to ax plus c. And of course, I really should have said this, must assume, okay, so let me say it in red, must assume that that a does not equals to 0. Does not equal to 0. Okay, so this is it. Thanks for listening.